Welcome to this ELV Engineering Explainer covering Lesson 8 of CCTV design. Today, we're going to unpack two recording architectures that honestly look completely identical when you're just flipping through a glossy sales brochure. But as you'll see, they behave completely differently when you actually deploy them in production. We are diving into NVR versus VRM architecture. To start things off, we really have to address a catastrophic operational risk. This is the baseline consequence of standard architecture. Think about it. When a single traditional NVR server goes down, every single camera connected to it loses its path to storage. Period. Every connected camera instantly dies and stops recording because they literally have no other way to get their data to the hard drives. As engineers, we have to look at that massive single point of failure and ask ourselves, is this actually acceptable for our project? So to systematically engineer a solution, we'll cover architecture basics, scalability limits, resilience, network bandwidth, a sizing case study, and we'll wrap up with some firm engineering rules. All right, Section 1, Architecture Basics, Server in the Path versus direct-to-iSCSI. Okay, so most VMS systems out there use a server in the path architecture. This includes your classic dedicated appliances like Hikvision and even software servers from Milestone, Hanwha WAVE, Avigilon, and Genetec. Basically, a server sits right in the middle. It pulls the video in, processes it, and then writes it out to storage. That means every single video frame passes through the network and that NVR server twice. Now, contrast that with Bosch BVMS using a video recording manager, or VRM. The VRM doesn't sit in the recording path at all. It simply acts like a traffic cop, handing each camera a list of iSCSI storage blocks, which allows the camera to write its data directly to the storage. The VRM manages the block list, sure, but it never actually touches the video itself. Moving on to Section 2, Scalability Limits. Let's look at the hardware footprint consequences of this. Because the VRM never touches the heavy lifting of the actual video data, its hardware footprint is incredibly light. In fact, a single Windows machine running just one VRM instance is rated to handle up to 2,000 cameras, right according to Bosch BVMS specifications. Compare that to a typical mid-range NVR for, say, a hospitality project, which generally maxes out around 64 channels. So 64 channels versus 2,000 channels on a single machine. The difference in your server rack space is just absolutely staggering. Now, obviously, there are physical limits to everything, right? The system-wide BVMS management server limit is also capped at 2,000 cameras total. But when your mega development scales beyond that 2,000 camera limit, you don't just endlessly stack NVR appliances on top of each other. Instead, you simply deploy multiple management servers within an enterprise BVMS architecture. It's a clean, methodically planned expansion rather than just managing a messy, sprawling pile of hardware. Section 3, Resilience. What actually happens when the hardware fails? Well, even if you invest top dollar in high-end NVRs with N+1 failover redundancy, you still require a completely separate standby server sitting there waiting. And here's the kicker. During that switchover period, valuable video frames are simply lost. But if a VRM fails, the recording just seamlessly continues. Because the cameras already hold their iSCSI block list, they keep writing directly to the storage for up to 7 days without dropping a single stream. The camera even remembers the last 32 blocks of its recording, so a brief replay still works perfectly, even with the VRM totally offline. Section 4, Network Bandwidth. Let's talk about the cost of crossing the network twice. So if we look at an 800 camera project running at 2 megabits per second per camera, a standard NVR architecture demands a massive 3.2 gigabits per second of network traffic. Why? Because of that double pass we talked about. The VRM architecture, on the other hand, demands exactly half of that, just 1.6 gigabits per second. And let me tell you, that 1.6 gigabit difference literally dictates whether your project is going to require a much more expensive 10 gig core switch, or if you can comfortably get by with a standard 1 gig core switch. It's a real game changer for the budget. All right, Section 5, Sizing Case Study. Let's apply this to an 800 camera 5-star hotel. Let's break this down side by side. With standard Hikvision NVRs, you're looking at needing 13 separate servers, 1.5 petabytes of attached storage, and you are facing the highest operational risk. That is 13 separate machines you have to individually patch, monitor, and eventually replace. Now, moving to Milestone X-Protect, you'd use recording servers with optional failover and a 1.4 petabyte SAN. It runs on standard hardware, offering mid-tier cost and mid-tier resilience. But with Bosch VRM, you only need 2 VRM servers, a primary and a failover, plus 1 management server, running 1 petabyte of enterprise iSCSI on DSA E-Series storage. Yes, it has the highest upfront hardware cost, but it drastically lowers your operational risk and your long-term management footprint. Finally, Section 6, Engineering Rules, making the final call. Look, standard NVR architecture is perfectly fine, and frankly, it's cheaper for retail shops, residential buildings, and small offices under 64 cameras where there just isn't a strict resilience requirement. But VRM becomes mathematically and operationally mandatory for large-scale facilities. We're talking hotels above 200 cameras, hospitals, mega developments, and critical infrastructure. Anywhere uptime actually matters, or where the scale exceeds what a single NVR can reliably handle, VRM wins, hands down. So to wrap this up, follow these 3 engineering rules. Rule number 1, for projects over 200 cameras, specify VRM or an equivalent direct-to-storage architecture. Do not accept NVR-based proposals at that scale without some very serious justification. Rule number 2, size your redundancy at the architecture level, not just the hardware level. N+1 NVR hardware swapping is simply not the same thing as a 7-day, camera-level direct-to-storage resilience. And rule number 3, let the required uptime dictate your design. Actually read the service level agreement, the SLA, before you specify the system. As we close out this explainer and prep for our next lesson, which, by the way, will be on CCTV network switch design, leave yourself with this critical question to challenge your daily engineering habits. Are you really reading the SLA before you spec the system? Ultimately, the choice between NVR and VRM isn't just about picking a favorite brand. It's about engineering a solid guarantee. Thanks for joining me today. Hit subscribe and keep building great systems.